Hey guys, and this is our guided practice video that we are working on for our particular session on Zoom. If you're watching during the 2020-21 school year, you are in the pandemic and we are virtual learning. So this video was what we went over in our Zoom session. If you're just watching it to get exponential knowledge, then awesome. But we're going to go ahead and dive right in. So in this particular video, we are going over exponential growth and decay functions. And our formula looks a little bit different from how we graphed them in the coordinate plane because we are about to be dealing with exponential growth and decay word problems. So there's just a little bit of tweaking going on. Instead of our y equals a times b to the x power, we have a little bit of adding and maybe even subtraction going on because we're going to be dealing with a rate. Inside of our word problems. So today is just diving into those, having an introductory level to those word problems. So we're going to start you off with a warm up. So what does it mean when a bank gives you interest when you save your money with them? So I have a banking account, I have checking, and I have savings, and then I have a certain percentage that they pay on interest. So then at the end of like maybe a month, I think it's every month, I get just a little chunk of change from the bank. So whenever they're paying something on interest, they're adding that onto you're getting money, or it's being added, and it's based on a particular percentage, whatever you set up with the bank and what type of bank account you have. So in order to really dive into our exponential growth and decay functions today and our word problems, we need to make sure that we remember the concept of converting percentages to decimals. So we're going to go ahead and review that here just a little bit. So as I am looking here, I have 10% and I need to convert that to a decimal. So by doing that, I am going to take my 10% and I'm going to divide by 100. So what really happens though with that when the thing doesn't work for you to write, back to web paint, the backup that it's always there for those videos. Now we're going to be about tired of me not being able to draw on this. Okay. So we have 10% and we're going to be dividing by 100, which technically is just changing that place value 2 times. So 10% written as a decimal is 0.10. Now you can go ahead and add the 0.10 if you would like to. If I was going to take the 1% and convert that to a decimal, I'm going to move it back 2 times. So that decimal is going to look like 0.01 or 100. This is a 10. Okay, if I have 4.6%, I'm going to take it back 2 times, dividing by 100. That's represented by changing the decimal place 2 times, dividing by 10 once, dividing by 10 twice, and that is going to give me 0.046. And then if I happen to have 300%, changing that to a decimal, I'm going to move it 2 times, 1, 2, so 300% written as a decimal will be 3.0. Let's go ahead and add that 0 onto the very end. Okay, so it was just a very quick recap of converting percentages to decimals because we're going to be using that concept in that particular standard and skill in today's lesson. Let's go ahead and dive right into it. Maybe. Mouse. Oh, now it wants to draw. Oh, okay, cute. So growth or decay. So we have crystal here. And let's see, is it really going to let me draw? Nope. It just did for like 2 seconds. Anyways, okay, so we have Crystal and she was given $3,000 whenever she turned 2 years old. I was given that amount of money. Her parents invested it at a 2% interest rate compounded annually. No deposits or withdrawals were made. Write an equation to represent how much money she has in this account. So eventually we're going to be writing equations, but today I just want you guys to really identify, is this a growth or is this a decay question? Okay, so some keywords that I saw in here was that they invested at a 2% interest rate. Okay, so if they're investing something, that particular amount is going to increase. So you're going to see that $3,000 start at a particular 0, and then it's going to increase exponentially. I can never say that word right. So with that being said, this is going to be one of those exponential growth questions and problems that we'll eventually be setting up. But right now, we are just going to identify whether it's growth or decay, so we know which particular equation to use once we start writing them. So this one was a growth, and my keyword in this one was they were investing money. It was an investment. Okay, at a 2% interest rate. Okay, let's go ahead and dive into the next problem. Okay, Puerto Rico's population has been declining at a rate of 3.136% per year since 2013. The population in 2013 was 3,509. That's not 3,000. Anyways, I thought that was a decimal point, and it was not. But our keyword here is really figuring out whether it was growth or decay. And I'm going to say that it was a decay. And the key word that I am seeing is declining. Okay, so the key word was a decline. So my population was declining, so my exponential function is going to be a decay, or it's going to be a decrease. So it's going to start at a particular point, and then it's going to decay or decrease. So again, your keyword in this particular problem was declining, so it is a decay instead of a growth. Okay. Next one, example 2. The country of Benin in West Africa has a population of 9.05 million people. The population is growing at a rate of 3.1% each year. So this one was easy. It even has like the word in it. So this is a growth. And my keyword there was growing at a rate. So my keyword was growing. So I know that this is a growth equation, or a growth function, or exponential growth function. Okay. Moving on to our last brief example of what type this is. A powerful computer is purchased for $2,000, but on an average, it depreciates by 20% each year. So depreciates is a keyword for a decay, or it's going to decline. It's declining, decreasing its value. It's depreciating. So if something depreciates, it's losing its value. And it's losing that by 20% each year. And again, we're going to really dive in to what that looks like as we set up our equations, moving a little bit forward, a little bit in today's lesson, but definitely into the next lesson that you guys will be completing. Okay, so what's next? We have our particular formula for exponential growth function. So you have your final amount, which is your y, what your equation is equaling. You have a, which is your initial amount, and then 1 plus r. We are using the plus sign to represent a growth equation, and you guessed it, we're probably going to be using a subtraction sign to represent the decay. So the plus sign, again, goes with our growth equations, and you can tell that the two examples here that I have on my screen are growth equations because without, like, it's not with the words, but because of the plus sign here, and if I move my web pane here out of the way for you. Also looking at it, I know if I add 1 to something, it's going to be bigger than 1. So this number right here is 1.025. So it had 1 added to it. So if I was to subtract 1 in my growth equation from my form that I have, up there in the box would be 3,250 times 1. Why did I write the plus sign instead of the number 1? 1 plus 0.025. Okay, so there you have 0.025 as your rate. So you can also change that into a percent if you wanted to. So if my particular question asked me what is the rate of each of these, you can see that the rate is the R value. And let me use, I didn't quite go far enough there for purple. So my R value is what's being added in a growth equation. So my rate is 0.2, or if it's asking you in percent, you just multiply that by 100 and it would be 20%. Okay, for this one, your rate would be 0.025. And again, I had to do a little bit of critical thinking here and some skills to figure out what that decimal was going to be. Or when I multiply 100, my rate would be 2.5%. Okay, so hopefully that wasn't too confusing there. If you need to pause the video and just kind of jot down or think through that, you can. I'm going to go ahead and erase so we can move on to the next one just to save time in this video, but you guys do have the features to pause, rewind, and fast forward. Okay, moving on to the next one, let's look at a decay. So on this one, you guessed it, if we added on growth, we're going to be subtracting on a decay problem, and you can see that there is a subtraction sign there that is letting us know that this has a decay. So with that being said, as I look into this, I need to find the rate. Trying to get as close to purple there as I can. So the rate on this one is what's being subtracted. So my rate here is 0.1 or 0.1. And if I need to find the percent, I'm going to multiply that by 100 or it's 10%. Okay, now this one, we know it's a decline or a decay or a depreciating, and it's an exponential decay problem because it happens to be less than 1. So you guys need to think, if I have that 1 subtract something is going to give me 0.12. Okay, now once you kind of grasp this concept, you're not going to have to set up the equation anymore to figure it out. But basically, you're going to take 0.12, okay? This is all the algebra, and I'm probably going to need a little bit more room. So let me work over here. So 1 minus x is equal to 0.12. Because I took 1, remember, right here. 1, I subtracted some number, and I got 0.12. Okay, so if I subtract 1 on each side, negative x is equal to, I don't know where my picture went, but okay. And let me make sure that I'm doing this right. So 0.12 minus 1 gives us 0.12. 1 gives us negative 0.88. We know we can't have a negative variable, so we have to divide by negative 1, and so x is positive 0.88. Okay, so our particular rate is 0.88, which is 88%. Okay, now technically there's an easy way to do all of this. Okay, if we just reverse it, we'll kind of reverse. I'm going to use that word very, very loosely. If I take 1 subtract 0.12, I'm going to get my rate, which is 0.88, which is exactly what I got down there. But I wanted you guys to really see the mathematical way in which technically we're supposed to get that rate number. But instead of doing like we did before and we subtracted 1, we're going to take 1, subtract the number that is given. So hopefully that's not too confusing. If you need to pause and rewind and kind of rework and recap that, you are more than welcome to. But let's go ahead and dive on into the next problem. Okay, so identify parts of this exponential function. So looking at the equation, is it a growth or is it a decay? So I'm going to take a look at the number that is inside right here. And this number is 0.35. It is less than 1. So it is a decay. My initial value is hanging out in the front of that parentheses, so it was 12. And the rate, because it was a decay, I need to take 1 minus 0.35. Unless you want to divide by a negative number, then you're more than welcome to. But my rate for my decimal is 0.65, and written as a percent is 65%. Okay, for this one, we notice that it is bigger or greater than 1. So this one happens to be a growth. So in order to find that, I'm going to do 1 minus 1.12 to find my particular rate. And my initial value is right there out in front being, 35. 35. Okay, and if I'm taking 1 minus 1.12, I'm going to get 0.12, which is 12% for my rate. Okay, next one, is it a growth or a decay? Well, this particular number is bigger than 1, greater than 1, so it is a growth. My initial value is 12. And my rate, if I take 1 minus 1.35, I would get 0.35, and written as a percent is 35%. Okay, last one, growth or decay. I have 0.12, which is less than 1, so that's a decay. My initial value is 35, and if I was to take 1 minus 0.12, what value am I going to get? I feel like we just did that in another problem. I'm going to get 0.88, which happens to be 88%. So there's how you identify whether it's a growth or a decay in your particular problem. And then also how you're going to be finding your decimal and or your percent for the rate. Don't forget that initial value is hanging out in front of those parentheses. Okay, let me clear this off. Okay, so overall, just a brief recap. If we have a celebrity that has that many followers, 150,000 followers on Twitter, the number Y of followers increases by 35% each year, right? An exponential growth function. So we're really going to dive more into this the next day that you do your lesson. Don't know where. Oh, hey, my face is back. But we're going to go ahead and dive just to do a very quick part on this particular video, and then the next video is going to go more in depth. So our final amount is Y. Don't forget A is your initial amount. So let's dive into my equation to figure out how much they started with. That would be your initial. And it started with 150,000. So 150,000 is your initial amount. It was a growth because it was increasing. So I know I'm going to take 1 plus. We have the rate being 35%, but in my equation, I need to write that as a decimal. So 35% as a decimal gets written as 0.35. And then it's asking me for the time, and that is in years, which is what is given in my particular problem. And those time in years is right here. Right there. Maybe not. Right there is 4 years. So we're taking the pieces that is given inside of our word problems and putting them into the formula. But again, the next particular video in this lineup is going to go more in depth into that concept, okay? And one more just brief as we're going through a decay problem. Okay, this one here, we say that we have a motorcycle, it's used. We bought it for $12,000. So Y equals, we need to find our A. And this one is one that's decaying because my keyword right there was decreases. So I'm going to be subtracting. I just want to go ahead and get all of the black ink that I needed to write down out of the way so I don't have to switch so much. Okay, so let's look for our initial amount. It was 12,000. Okay, let's look for our rate, which is our percentage, but we know that our particular form that we have, formula, needs to have it written as a decimal. So if we have 15%, and my decimal place goes there, I'm going to divide by 100 to make it a decimal, so 0.15. Okay, and then last but not least, I need to figure out how many years this is talking about, and it wants to know after 5 years. So I would place 5 right here in where the time goes, which is located right there in your exponential form. So that was a very brief introduction of whether it was a growth or decay. And again, your key features to look at, if I go back to that particular slide, I wonder if it will take me back. It is just kind of slowly. So your key thing to look at is whether it's adding or subtracting in your particular formula. And then also you want to look at, is it greater or is it less than 1? So that's going to be your key indicators of whether it is a growth or a decay. And then don't forget that your initial amount is hanging out in front of those parentheses. Best of luck on your assignment today. And as always, I'm just a private comment on Google Classroom or an email away.